Let's look at another way of figuring out trig ratios, and specifically algebraically. Now, this lesson is more relevant for angles that are not within the unit circle. So, even though you've memorized the unit circle in radians, it might be helpful to evaluate a trig ratio in radians algebraically. So, let's talk about what that means. All right. Right off the bat, we're going to do a very big angle, 97 pi over 6. Now, that is very extreme angle. And we know that's not on the unit circle, okay? It's well past 2 pi. So these are the steps we're going to do in order to evaluate this expression. We're going to take this radian and convert it to degrees. So we just learned how to do that. We're going to multiply by 180 over pi. The pi's will cancel. Then you'll have 180 over 6, which is 30. Let's go ahead and cancel these pi's out. And then 97 times 30 is 2,910. And that is degrees. Okay. So that's what we have in degrees. Now, that's still not on the unit circle, right? But we've learned how to do that also, okay? We've learned that all you have to do is keep subtracting 360 until you end up with an angle that is between 0 and 360. We want to find an angle from here that's equivalent to 2,910, but is between 0 and 360. So we're just going to keep subtracting 360 until we get there. All right. Now I've already done the work here. If you subtract 360 8 times, you end up at 30 degrees. So 2,910 is the same as 30 degrees. So therefore, when we're really evaluating cosine of 97 pi over 6, it's actually the same exact angle, reference angle, as 30 degrees. And here it is on the unit circle. So this is actually the same thing as 97 pi over 6. You end up at the same point on the unit circle, which is at 30 degrees. So you can see this is helpful when the angle is too big to even try to figure out what that would look like visually. Just convert it to a degree that's between 0 and 360. Now, what is our point on the unit circle at 30 degrees? Pull up our unit circle. No, it's the same as pi over 6. There it is. It is square root of 3 over 2, comma 1/2. So after we locate the angle, we will write the point, square root of 3 over 2, comma 1/2. What is our coordinate identity for cotangent? It's x over y, so we're going to be 1/2 divided by square root of 3 over 2. I'm sorry. Glad I caught myself. Square root of 3 over 2 divided by 1/2. This is our x, this is our y. This illustrates the importance sometimes of labeling points. Okay. So it would be square root of 3 over 2 over 1/2. Keep, change, flip. Answer is square root of 3. Therefore, cotangent of 97 pi over 6, as crazy as that looks, is simply equal to square root of 3. Let's do another one. Sine of negative pi over 2. Well, this is a negative angle. All you have to do, again, is convert that to degrees, multiply by 180 over pi. The pi's will cancel. You end up with negative 180 over 2, which is the same as negative 90. Now, that is not a standard angle. Since it's negative, all we have to do is add 360 to it. We know we'll end up at the same angle. Negative 90 plus 360 is 270. Now we have a point on the unit circle. 270 is just 3 rotations of 90. So 1, 2, 3. That point on the unit circle is 0, negative 1. We can pull up our unit circle app and see that quickly. And we know that sine is what? Sine is the y value, right? So right off the bat, we can see that the answer is going to be negative 1, since sine is y. Therefore, sine of negative pi over 2 equals negative 1. And no simplification needed for this. It's just negative 1, the y value. And another way of looking at this problem, 1 second. If you notice, pi over 2 is one rotation 90 degrees. Negative pi over 2 would be one rotation 90 degrees clockwise instead of counterclockwise. And you'd still end up at negative 1 for your y value, which means sine of negative pi over 2 would be negative 1, the same as sine of 3 pi over 2. So sometimes you can do these visually, but at the end of the day, algebraically, it's consistently always works, especially with really big extreme angles or really extreme angles in the negative direction. That's it for this lesson. If you have any other questions, about converting from radians to degrees, degrees to radians, or finding trig values at extreme angles, let me know.